Welcome to Week 16 of our AI Literacy course. Today, we explore bias, stereotypes, and representation. To evaluate systems effectively, we use the FAIR process. Find the pattern, ask who is affected, investigate through comparison, and respond with action. Remember, a review only matters if it leads to accountability and follow-up. It is important to remember that a single AI output is just an example, not a pattern. We must avoid generalizing from one instance. Only when we see the same outcome repeatedly under comparable test conditions should we investigate whether a pattern exists. We must distinguish between an example, a pattern, and an actual impact. An example is one observation. A pattern is a recurring difference. An impact occurs when an output affects a real person's life. Always remember, evidence and consequences determine the response. Bias extends far beyond just offensive language. It manifests in who is visible, who receives opportunities, whose language is understood, and who is unfairly associated with risk or error. Even a polite answer can distribute harm unequally. We need to analyze bias, stereotypes, representation, and unfair effects as distinct but connected concepts. Bias is a trend, stereotypes are group-based assumptions, and representation covers how people appear. Always describe the evidence before naming your conclusion. Even apparently positive stereotypes can restrict people. By assuming traits or roles for a specific group, we create unnecessary pressure and risk excluding others. Such group praise can effectively erase individual differences. Representation is about more than just a head count. We must look at who has a voice, who is granted agency, who is portrayed as an expert, and who holds power. Remember, equal presence does not guarantee equal influence. When evaluating AI, avoid making unsupported leaps. Observing a difference in a test is not the same as determining legal discrimination. Describe the observed effect first, then refer the concern to those with the appropriate expertise. Representational harm shapes how we imagine people and possibilities. When groups are absent, stereotyped, or simplified, it changes our understanding of the world. This type of harm is profound because it defines the boundaries of the status quo. Allocative harm directly affects resources and opportunities, such as jobs, healthcare, or credit. Because these systems have high-stakes consequences for real people, they require formal investigation and strict safeguards to protect users. Different harms require different responses. A stereotyped image might be addressed by changing a prompt, while an unfair recruitment system requires a deeper investigation and potential system suspension. You must always match the mitigation to the actual consequence. Bias can enter the system at any stage, from the initial purpose to how humans interpret the final results. You cannot rely on fixing the model alone. You must also examine the institutional policies and data practices behind the system. Historical data often carries the baggage of past exclusion. If we don't change how we collect and process data, scaling up these systems will only scale the existing inequalities. Remember, more data does not automatically mean more representative data. Labels are essentially human judgments, not neutral facts. When we label a, quote, successful employee, we are encoding the biased standards of previous managers. If that label becomes a training target, the AI will inevitably learn and repeat those same biased judgments. Finally, be wary of proxy variables. Even if you remove explicit group labels, features like postcodes or language patterns can act as indirect proxies for sensitive information. Simply removing labels does not guarantee fairness. Now, let's examine how to identify a proxy. Use 6 questions. What is the purpose? Is it relevant? Does it reproduce group differences? Is it reliable? Are there less harmful alternatives? And are the consequences distributed unequally? Remember, context is key. Average performance can often mask harm to specific groups. By testing one category at a time, we might miss combined effects. For instance, a system might work well for women and older speakers separately, yet still fail for older women who use a specific dialect. While analyzing combined effects is vital, we must still protect privacy. In the classroom, use fictional cases to avoid identifying real people. When working with real data, proper authority and rigorous safety protocols are always required to minimize risk. We must be aware of automation bias, which leads us to trust computer output as inherently objective. Precision and consistent formatting can make results look scientific, even when the underlying data is flawed. Never assume a calculation is fair just because a system produced it. True human review goes beyond simply approving output. It requires access to the context, enough time to inspect, the authority to reject, and the responsibility to document findings. Anything less is not effective oversight. There is no magic make-fair setting for AI. Fairness is a balancing act between different goals, such as error rates, equal opportunity, consistency, and avoiding historical bias. Each improvement might create new trade-offs that you must consider. To perform a responsible fairness review, be specific. Name the purpose, the people affected, the rights at stake, the types of harm, and who holds the authority to make decisions. Vague claims of fairness don't help. Reasoned decisions do. Use the FAIR framework to guide your investigation. Find the pattern, ask who is affected, investigate with comparisons, and respond with accountability. This structure helps turn surprising results into actionable evidence, rather than just a subjective verdict. Step 1 of FAIR is to find a precise pattern. Avoid vague questions like, is this AI biased? Instead, ask if the system repeatedly assigns different roles across variants. A clear, measurable question makes investigation possible. Step 2 is to ask who is affected. Consider presence, agency, error rates, and opportunity. Different identities can intersect in complex ways. The severity of the harm determines our testing priority, so always focus on where the most significant risks lie. Step 3 is to investigate through controlled comparison. Change only one factor at a time, like the input variant, while keeping everything else stable. Record everything you do, date, prompt, language, and settings, and avoid the temptation to cherry-pick the most dramatic results. Finally, step 4 is to respond with accountability. Based on your evidence, you might revise the task, remove a proxy, reduce the AI's influence, or provide ways to challenge outcomes. Always designate a responsible owner and set a date for review. Remember that classroom tests have limits. Factors like randomness, model updates, and prompt wording mean results may vary. A test can reveal a potential pattern worth looking into, but it is not a final proof of universal system behavior. When reporting your findings, clearly separate your observations, your interpretations, and the limitations of your test. Don't leap to conclusions. Use language that reflects the evidence you have collected, rather than making broad, unsupported claims. For high-impact systems, ensure affected people have voice and recourse. True contestability includes access to human contact, the ability to challenge outcomes, and a clear path for correction. If your process offers no way to change a decision, it isn't truly oversight. When sharing your findings, it is vital to report what the system produced without repeating stereotypes as truths. Preserve only the necessary evidence. Avoid republishing harmful examples unnecessarily, and always state the tested question, methods, and limitations alongside recommended actions. To conduct a controlled representation check, use a harmless teacher-approved task. Define a potential pattern, change one factor while holding conditions stable, and collect several outputs. Code these for presence, role, agency, and errors, then explain the limitations and recommend an accountable action. A fair AI review connects evidence, identified harms, and clear accountability. Notice the pattern, compare carefully, and limit your conclusions to the evidence found. Assign responsibility for follow-up, because a review without ownership and clear action will not improve the system.